Okay, so the problem says that a rope is used to pull a 3.5 kg block. So here is the surface, and this is the block 3.57 kg, and the force is 7.68 Newton and directed 15 degree above the ground. So basically force is somewhere there, very small angle, 15 degree, looks more than 15 though, but whatever. So this is the force there, and the questions are, what is the work done by the rope's force? So the block moves at a constant speed and it moves 4.06 along a horizontal floor. So the work done will be the force in the horizontal direction, that will be F cosine of theta times the distance. So that will be 7.68, and then cosine of 15 degree times 4.06, which is 30.1 joules. The second part is, what is the increase in the thermal energy of the block floor system? So since the block is moving at a constant velocity, the force, the energy, the work done due to force will be the work done against the friction force, and that is the thermal energy, increase in the thermal energy block force system. So basically because of the friction there will be an increase in the thermal energy, which will be converted from the friction force. So that will be, that change will be, the increase here will be same as, so if we say thermal energy, that will be 30 point same energy. And finally, what is the coefficient of friction between the block and the floor? Now this force, this is the horizontal component, and there is also a vertical component which is F sine theta. So also the block has a weight force which is downwards, mg. So friction force will be equal to the downward force times the frictional coefficient. So, and with against that force the pulling force is working. So the frictional force downwards is mg minus F sine theta. This is the applied forces vertical component, and this is the weight force. This one, when we this is the total downward force, and the frictional force is, if we say F friction, I don't know, F I'll just write it lowercase f friction, that will be this downward force times the frictional coefficient, which we can say mu. So that is the downward force. So against that this force is working, and this horizontal force will be equal to this force, this one. So basically this one, mg minus F sine theta. Now if there was an acceleration, that force, this force would have to work for that acceleration as well, but in this case a is 0, so there is no acceleration force. Otherwise there would be an acceleration force as well, like ma. Anyway, so in this case there is none. So we have mu equal to, we get mu as f cosine theta, just a sec, f cosine theta, and here mg minus F sine theta. So that one is 7.68 cosine of 15 degree, and then 3.57, which is m, times g, which is 9.8, minus 7.68 sine of 15 degree. And when we solve this, we get the frictional force to be approximately 2, 2. So frictional coefficient approximately to be 2, 2. So that is the frictional coefficient.